Hi guys, this is another video by Darklink Does Math. The content in this video is geared towards 6th grade math standards. These videos are public so that my students may access this information easily, as well as anyone else looking for math help. I hope you find this video helpful. If you do not, I hope you can find what you are looking for elsewhere. There's a lot of information out there. Be aware that I'm not perfect, so there may be the occasional mistake. I apologize in advance if this should happen. Today, we're going to be going over 7.1 guided notes, writing algebraic expressions, specifically how to use letters to represent numbers that are unknown, or specifically how to express answers to problems when you don't know all of the information. So our first vocabulary term is variable. Variable is a letter that represents an unknown quantity it can take on different values. Quick example. Let's say I had an algebraic expression of 2x plus 1. The variable is the x. That's not a multiplication symbol. So our variable is the x. It can take on different values, meaning x could be 1, it could be 10, it could be 20, it could be -3. We don't know. So that's why we're using a letter. Also, when choosing letters to represent unknown values, it's best to choose letters that don't look like numbers. All right, our second vocabulary term is an algebraic expression. So these are what we're going to be writing, algebraic expressions. Algebraic expression is an expression that contains at least one variable and no equal signs. If it has an equal sign, you're talking about an algebraic equation, which we will get to in another lesson. So for now, we're just dealing with algebraic expressions. That would be expressions with at least one variable, but no equal signs. So an example of what this would look like, I've already got an example up here, 2x plus 1, but another one would be 3y minus 2. And another one would be y over 2, or y divided by 2. That can be read different ways. These are examples of algebraic expressions. Our last vocabulary term, terms. We're talking about terms of an algebraic expression. So the definition of this would be parts of an algebraic expression. And I just misspelled that. There's probably lots of other spelling mistakes. I shudder to think. All right, parts of an algebraic expression. So, quick example. Let's say I have, in the example, 2x plus y minus 14. There's lots of unknowns. So I don't know what x is. It's standing in for a number. It could be 1, it could be a million. I also have y, so I have two variables in here. So 2x plus y minus 14. The terms are, so in other words, the parts. There are three parts. The 2x, the positive y, and you can write the positive sign in front of it, and the negative 14. Since it's negative, you have to have the negative sign. You have to have it. So 2x, y, and negative 14. So there are 3 terms in this particular algebraic expression. If I look at the one up here that we started off with, 2x plus 1, the 2x is one term, the second term is 1, or positive 1. All right, some practice problems. We're going to go through the 4 major operations: addition, subtraction, multiplication, and division. We're going to go through traditional math examples with no variables, and then we're going to introduce the same type of problems, but show you how letters can be used. So to start off with, we're going to start by dealing with no variables, no letters. And then we're going to do it with variables. All right. Our first example. Anna has 3 apples. She gets 1 more apple. How many apples does she have now? So think, what does 1 more mean? It means you're going to add 1, right? So what do we start with? She starts with 3 apples. She gets 1 more, so plus 1. We now have an expression. It's not an algebraic expression because it does not have at least one variable. It's just an expression because there's no equal signs and I have numbers and operations. Can I simplify this expression? Meaning, can I combine these things together? Absolutely, I have a number and a number. They can go together. So 3 plus 1, we're going to get 4. So how many apples does she have now? She has 4 apples. Let's do one more. Again, Anna still has 3 apples. She gets 4 more apples. So how many apples does she have now? So we have changed what happens. 4 more. Again, that's going to be plus 4. So she starts with 3 again, but this time instead of adding 1, she's going to get 4 more apples, and she's very happy about that. So add 4. So we have our expression here. Can I combine those terms? Can I combine 3 and positive 4? Absolutely. They're both numbers. They're like each other. We're going to get into another lesson about like terms, but I'm going to be using that a lot in this lesson. So these are like terms. They're like each other, 3 and a 4. So I can combine them and make 7. So how many apples does she have now? She has 7 apples. So the number of apples she has changed according to what she got more of. This example, she got 1 more. This example, she got 4 more. Now let's take the same example, but do it with variables. So that means there's going to be some information we don't know. All right, Anna has 3 apples again. Her friend gives her some apples. Does it tell you how many apples? No. So what do you do to find out how many apples she has now? Well, first, think about the sum apples. If you don't know how many apples she got, you need to use a letter. And in this case, we're just going to use x. X is used a lot. We're going to use x to represent the unknown number. And I really can't spell today. So we're going to use x to represent the unknown number. We don't know how many apples, just some. So we're going to use x. Think of it like using a question mark. All right, so to visualize this, think she's got 3 apples. She gets some apples from her friend, right? So some apples. We have no idea what that is. And we're going to represent that with x. So some apples. It could be 1 apple, it could be 4 apples, it could be 20 apples, in which case you'd be really excited. And what do we want to know? We want to know how many she has in all, right? So that means we're going to add. So we're going to take what she had. We're going to add what she got. We don't know how many she got, so we're using x to represent that. So we have 3 plus x. Now, are these like terms? Meaning, are they like each other? Well, they are not. I have a number, I have a letter. They can't go together. Absolutely not. So if I said, what is 3 plus x? Well, because you can't combine, the answer is simply 3 plus x. So what is 3 plus x? 3 plus x. There's not a darn thing you can do with them. You can't do anything with it except for, we'll just look at it. So this is an expression. We're expressing how many apples she has. She has her 3 plus whatever her friend gave her. Now we're going to put that in a sentence, of course. So we're going to say she has 3 plus x. Since this is one whole answer and we need to put a label on it, we're going to put this in parentheses. She has 3 plus x apples. When you have more than one term and you need to put a label, put your terms in parentheses. So again, unlike combining 3 and 4 to make 7, I can't combine the 3 and the x. So it stays as 3 plus x. So that's how many apples she has. We have expressed the answer when we didn't know stuff. All right, before we move on, let's go over some adding words that you might encounter that tell you you should be adding. If you see words like the sum, or the obvious add, or more than. Not them, than. All right, there we go. That means you're going to add. All right, let's move on to some practice examples. Or I should say, some more practice examples for addition. So in these 3 examples, we've got traditional math, no letters, and then we've got introduction of variables. We're going to compare and see how similar they are. So in number 3, part A, we're going to add 0 to 6. So add, obviously, you're going to plus. What are we adding? We're going to add 0 to 6. Can I combine these? Absolutely. I have 2 numbers. They can be combined. So 0 plus 6, I get 6. Now notice, or you should know that anything added to 0 is simply going to be itself, right? That's our identity property. Anything plus 0 is going to be itself. So let's apply that to letters. So again, add. That means we're going to plus, what am I going to add? 0 and x. Now what is 0 plus x? Well, in the other example, I couldn't combine the 3 and the x, right? Well, if you look at this one, anything plus 0 is simply itself, right? So in other words, I'm adding nothing to x. So what would this be? It would simply be x. We're not going to write 0 plus x because if I add nothing to it, it's still going to be itself. So this is completely simplified. Let's do some more examples. Sum. Sum means add. What are we going to add? We're going to add 11 and 3. So 11 plus 3. Can I combine these? Yes, they're both numbers. 11 plus 3 is going to be 14. Let's apply the same with letters. Sum, again, means add. I'm going to add n and 3. Now in this one, unlike adding 0, I'm trying to add an actual number to a letter. Can I combine these? No, you can't combine letters and numbers. So what is n plus 3? It is simply n plus 3. There's not a darn thing you can do with them. Nope, nothing. Not until you know what n is. So I'm expressing how to add n and 3. So this would be an algebraic expression. Third example, 4 more than 8. So it uses the term more than. More than means you're going to add. How much more than? 4 more. Like if I wanted 4 more cookies, I'm going to add 4 cookies to my plate, right? Not like 20 because it says 4 more. Not 8, 4 more. So what are we going to add 4 more to? 8. So we're going to do 8 plus 4. So that's my 4 more. Can I combine these? Yes, they're both numbers. So 8 plus 4, I get 12. So this would be like, oh, I have 8 cookies. I want 4 more. Add 4, you get 12 cookies. Then you've got diabetes. All right, next, 4 more than y. So again, more than means add. How much more? 4 more. So that means we're going to add 4. We're not adding y. We're not adding 10. Not adding 1. We're adding 4. So let's have 4 more than what? Y. So what is y plus 4? Can I combine these? Are these like terms? No, one's a letter, one's a number. There's nothing you can do with them. So y plus 4 is simply y plus 4. Again, why is this one x and not 0 plus x? Because anything added to 0 is going to be itself. Like if I said, what's 0 plus 1? It's going to be 1. What's 0 plus 2? It's going to be 2. Doesn't matter what x is. That's what your answer is going to be if you're adding nothing to it. All right, that's addition. We're now going to move into subtraction. So same setup. We're going to start with an example with no variables. And then we're going to transition into what it would look like with variables or letters. All right, first one. Paige has 20 granola bars. She does not need all of them, but she's happy. Part A. Kyle has 5 granola bars. We want to know how many more granola bars does Paige have than Kyle. So if it says how many more does Paige have, that means Paige has more, Kyle has fewer. How do I find out how many more she has? We're going to subtract. If you take whoever has the most and get rid of who has a fewer or fewest, you'll find out how many more they have. So we're going to start with Paige. We're going to subtract Kyle, which is 5. And we're going to come out with how many more she has. So 20 minus 5. Can I combine those? Yes, through subtraction. 20 take away 5 is 15. So how many more granola bars does Paige have than Kyle? We're going to say Paige has 15 more granola bars. Because she's got 20, he's got 5, so that means she's got 15 more. All right, next example. What if Kyle has 12 granola bars? How many more granola bars does Paige have than Kyle in this situation? So again, Paige has 20. If I want to know how many more she has, we're going to subtract how many Kyle has, which is 12. Can I combine these? Absolutely. Both of them are numbers. You can do stuff with them. So 20, take away 12, you're going to get 8. How many more does she have? We're going to say Paige has 8 more granola bars this time. And you'll notice that I said these can be combined. Combined does not necessarily mean add. So I'm basically, what am I combining here? 20 and negative 12. So think of these as 2 separate terms. So they can be combined. So you don't have to see an addition sign. All right, let's try the same example, but with variables. meaning we're not going to know stuff. All right, Paige has 20 granola bars. We do know that. Kyle has Y granola bars. What does this mean? This means we don't know how many granola bars he has. He could have 5. He could have 12. He could have 18. We don't know. So we're just going to substitute it with a variable. All right, same question. How many more granola bars does Paige have than Kyle? So we're going to think of this visually first. So we've got Paige. We've got Kyle. Paige has 20 granola bars, right? How many does Kyle have? We don't know. However, it says how many more does she have? So we know she's got more. So I'm just going to draw a smaller bar for him. He's got fewer. I don't know how many though. Again, we're using Y because we don't know how many he has. And we want to know how many more. So in other words, we want to know this part. So what are we going to do? Subtraction, just like the other problems. So we start with who has the most, 20. We're going to take away how many Kyle has. We don't know. So we're going to subtract Y. That's how many Kyle has. We don't know it. What is 20 minus Y? Can we combine these? Well, are they like each other? Are they like terms? 20 is a number. Negative Y is a letter. No, they cannot be combined. So what is 20 minus Y? 20 minus Y. Not anything you can do with them. You're as done as you're going to get. All right, so let's write our answer. How many more granola bars does Paige have? Paige has 20 minus Y. Since I have more than one term and I need a label, put them in parentheses. More granola bars. So, in other words, I'm really not going to know the real answer until I know how many granola bars Kyle has. Think of expressions like instructions on how to get the answer when you know your information. So, my instructions right here tell me that if Kyle has 1 granola bar, I'm going to take 20, take away 1, and I'll know that Paige has 19 more. We're going to get more into that next lesson. So expressions are like your instructions of how to get the answer when you eventually do get the information you need. All right, before we continue, let's go over some subtraction words. If you see the following words, it means subtract. So difference. If you see the words less than, younger than, the list goes on. There are many, many more. Those are just a few. All right. Like before, we've got 3 opposing examples, one with terms that can be combined and those with variables. And we're going to see how they look similar yet different. First one, we're going to subtract 3 from 7. Now, remember, subtraction is not commutative. You can't subtract in any order you want. So we're going to subtract 3. So that means take away 3 from the 7. So that means 7 comes first. Take away the 3, like it says. It doesn't say subtract 7. It says subtract 3. Can I combine those? Absolutely. Both of them are numbers. So 7 subtract 3 becomes 4. Now let's apply the same logic, but with letters and things that we don't know. So on this one, subtract 3 from A. So subtract 3 means we're going to take away 3. Don't take away A, don't take away 5, take away 3. That's what it says. What are we going to take it away from? The A. So A minus 3 means subtract 3 from the A, meaning I don't know what A is. A could be 10, it could be -1, I don't know. But we're going to have to subtract 3 from it. Can you do anything with this? No. These are unlike terms. One's a letter, one's a number. There's nothing you can do. It's as simplified as it will get. So A minus 3 is your answer. That's what subtract 3 from A looks like. Remember, order matters on subtraction. Order matters on a lot of things. Definitely subtraction, though. Next one. 1 less than 12. So, 1 less. What does that mean? Well, if I said, oh, Johnny's got 1 less cookie than I do, that means you would take away 1 to see how many he has. So 1 less means take away 1. So we're going to take away 1 from what? Well, it says 1 less than 12. Can I combine those? Absolutely, both are numbers. 12, take away 1 is 11. All right, let's compare that with letters. So 1 less than x. Again, 1 less than means take away 1. Don't take away 5, don't take away x, don't take away anything else. Make sure you're taking away 1 from what? X. So x must come first. So 1 less than x means x minus 1. Can I do anything with that? No. X minus 1 is x minus 1. You can't actually solve it until you know what x is. Don't try. People try to solve these all the time. No, it's not going to be like 10. I don't know what x is. Again, order matters. Meaning you can't do 1 minus x. Why? Because it doesn't say x less than. All right, next example. 2 years younger than 21 years. So think of a 21-year-old. If I said, oh, he's got a brother that's 2 years younger, how old would they be? Well, you'd say they're 19. How would you get that answer? Well, you would probably say you're going to subtract 2. So 2 years younger means take away 2. Don't take away 21. Don't take away anything else. So we're going to take away 2 from what? There needs to be a number right here. 21. So 21 years, take away 2 years, you're going to get 19 years. This one has a label. Don't forget your labels. All right, let's apply the same logic with variables, meaning stuff we don't know. All right, 5 years younger than Y, meaning there's someone and we don't know how old they are, but we know that we're 5 years younger than them. Think of it like that. So, just like this one, 2 years younger. If you want to know how old someone is, if they're 2 years younger, well, you'd take away 2. So if someone is 5 years younger, that means you're going to take away 5. So we're going to subtract 5 from Y. So our answer is Y minus 5. Can I combine these? No. So Y minus 5 is Y minus 5 is equal to Y minus 5. Again, order matters. You cannot say 5 minus Y. Why? Because it does not say Y years younger. It says 5 years younger. So you're going to have to take away 5. Next section. We are now coming to multiplication. All right. Like before, we're going to split it into 2 different sections. First section, we're going to discuss how to solve problems with no variables. And then we're going to see what it looks like with variables. All right, first example. Martina has 2 empty boxes, so she can put stuff in it. Great. Part A. She puts 12 chickens into each box. Why is she putting chickens into the boxes? I don't know. Maybe she's taking them to like Tyson's. Very sad. How many chickens are there in all? So let's think about this. 2 empty boxes. So we're just going to visualize it. So there's our 2 empty boxes. She's going to put 12 chickens into each box. They're excited. They think they're going on a road trip. Just not to where they expect. All right, next, we want to know how many there's in all. I could add these, true, but let's say I had many more of them. Well, then I get into what we call repeated addition. So how can I speed that up? Well, through multiplication, of course. So let's think about what we have. I have 2 groups of chickens, right? Our groups are our boxes. So 2 groups of 12 chickens each. Groups of means multiply. So we have 2 12s, right? 2 groups of 12. 2 boxes of 12 chickens each. So 2 times 12. Can I do stuff with that? Absolutely. 2 times 12, 2 groups of 12, that's going to equal 24. So how many chickens are there in all? There are 24 chickens in all. And they're so excited to be going somewhere. Maybe they're going to the farm. Who knows? All right, let's do the same type of problem, but with variables, with unknowns. All right, so Martina still has her 2 empty boxes. This time she's going to put in chickens into each box. What does that mean? We don't know how many chickens she's putting in the boxes. It's going to be the same amount every time though. All right, how many chickens are there in all? So again, let's picture this. We have our 2 empty boxes, and she puts in chickens in that box, meaning she doesn't know. And then she puts the same number in that box. She still doesn't know how many she put in the box. Maybe it's 12. Maybe she wants to put 24. Maybe she's trying to figure out how many chickens she would have depending on what n was. All right, anyways, how do I find my total? So what do I have? I have 2 groups, 2 boxes of how many chickens each? N. It might be 12, it might be 1. Think of this as a placeholder until she figures it out. Now what do I do? Well, groups of means you're going to multiply. So 2 groups of n. 2 times n. First, let me discuss the multiplication dot. We're to a point, we are no longer using x as a multiplication symbol. Do not put x as a multiplication symbol when you're dealing with letters. All right, let's answer this. What is 2 times n? Can I combine them? No, you have numbers and letters. They're not really going to do anything. So don't come up with, magic answers of like 5. Nope. So what is 2 times n? It is 2 times n. However, how do I write that? Multiplication has a few rules and a few different ways you can write this properly. The most preferred way is to literally smush the letter up the backside of the number, right next to each other. That means multiplication. This is the most preferred way of writing multiplication of letters and numbers. Just smush them together. Next, I could write 2 parentheses n. Parentheses mean multiply. Or I could also write it exactly how I had it originally with the multiplication dot, 2 times n. Again, all are acceptable. This is usually most preferred. Why? Well, it's the most simple. You just wrote a 2 and an n up its backside. So super easy, super quick. A note about the parentheses could be around the 2 or the n. That doesn't matter. All right, so what is our answer? How many chickens are there in all? She has 2n chickens in all. Real quick, why did I not put parentheses around this term, even though I had to put parentheses around my other answers, such as 3 plus x apples? Well, this one, again, has 2 terms with a label. 2n is just 1 term. I don't need parentheses around it. So, quick explanation. All right, let's continue. Most important rule for multiplying numbers and letters. You'll notice I kept the number in front. So our important rule when multiplying letters and numbers is when multiplying numbers and letters, or numbers and variables, the number is written first. So, even if I said, what's n times 2? I'm still going to write it as 2n, or 2 times n, or 2 times n. Number first. All right, let's do a few examples, side-by-side comparison, without variables and with variables. So, first example, we're going to multiply 1 by 4. Multiply, obvious, we're going to multiply. What are we going to multiply? 1 and the 4. So 1 times 4. Can I combine those? Can I do stuff with them? Absolutely, they're both numbers. So one group of 4, or 1 times 4 is 4. Let's try that with letters. Multiply 1 by y. So again, multiply. I'm going to multiply 1 and y. What is 1 times y, or one group of y? Well, I could say one group of y is 1y, or the most preferred is simply y. If I only have one group of y, that's all I have, is y. Again, this one's preferred. Either are perfectly acceptable. I just look at it this way. Why write 1y if I only see 1y? I like things simple. Also, 1 times y. Anything times 1 is going to be itself. It's kind of like the x plus 0 example. Our answer was x. All right, next, product of 5 and 4. Product means multiply. What are we going to multiply? 5 and 4. So 5 times 4. What is 5 times 4? Can I do stuff with it? Yes. 4, 8, 12, 16, and 20. That would be 5 groups of 4. Let's try that with this. Product, again, multiply. What are we going to multiply? We're going to multiply x and 4. Notice I'm using the multiplication dot to show that. This is what I'm not going to do. I'm not going to do x times 4 like that. That looks ridiculous. No, bad. Don't do it ever. Do not ever do that. Okay, what is x times 4? Can I combine them? Can I do anything with them? No. One's a letter, one's a number. I can't really combine them. However, this is not written appropriately. Remember, our rule is number first. So we've got a few different answers. Again, the best answer would be 4x. Simply push the letter up the backside of the number, all smushy smushy, right next to each other. That's your best answer. You could also say 4 times x with the multiplication dot, or last, 4 times x with parentheses. All are accepted. I find that the most easiest. Most people do. So again, preferred. All right, one more example. 4/5 of y, or sorry, not y, 5. 4/5 of 5. Of means multiply. So, it's a little crooked. We're going to do 4/5 times 5. Remember, when multiplying fractions, always put whole numbers over 1 if necessary, and multiply across the top. 4 times 5, 20. Across the bottom, 5 times 1 is 5. I have an improper fraction, so we're going to divide. 20 divided by 5, top divided by bottom, is 4. All right, let's try the same problem, but with letters. So 4/5 of w. So again, 4/5 of means multiply. We're going to multiply by W. There are tons of different ways you can write this. I'm going to stick with the most straightforward first one being put the letter right up the backside of the number. So 4/5 times W is simply going to be 4/5 W. Notice my W is dead center, not on the top, not on the bottom. Be careful with that. Again, not on the top, not on the bottom. Or, I'm going to write preferred real quick. And actually, this one kind of has two preferred answers. The next one, 4/5 W, but using parentheses. Or the last one, let's go back and actually try to solve it by hand like this one. If I took 4/5 times W, and I treated W like a whole number, and put it over 1, and then multiply it across the top, what's 4 times W? Well, 4W. Again, multiplication of letters and numbers, just smush them together. What's 5 times 1? 5. So notice, on this example, the letter ended up on top. That's also the other preferred answer. So 4W over 5. Same thing as 4/5 W, or 4/5 times W. They're all the same, but both of these are the preferred. And they all mean the same thing. What do you not see? The W on the bottom. We are not dividing by W. We're dividing by 5. All right, so again, this is multiplication of numbers and letters. Keep in mind, numbers are written first. And to show multiplication, pretty much you just smush the letter and number together. Or you can use your multiplication dots or parentheses. All right, last section. And you're like, thank goodness, because I've already sat through 42 minutes of this. All right, last section, division. We're going to follow the same format. No variables versus with variables. All right. Our example says 16 crackers were shared equally between 2 children. That's a lot of crackers for 2 children. How many crackers did each child receive? Shared equally implies division. What are we going to divide by? Well, there are 2 kids to split the crackers between, right? So we start with 16 crackers. We're going to share them, divide them, split them up between 2 children. So 16 divided by 2. Can I do stuff with that? Absolutely, they're both numbers. So 2 will go into 16 8 times. So how many crackers did each child receive? Each child receives 8 crackers. All right, let's try that example with variables. All right, there are C crackers in a box. What does that mean? It means we don't know how many crackers are in the box. It could be 16, could be 12, could be 10, could be 500. Until we know, we won't get a real answer. All right, anyways, the crackers are going to be shared equally between 2 children again. Shared equally means divide. How many crackers did each child receive? So if you were to picture this visually, think I have a box with crackers. I don't know how many crackers are in there, so C. It's a placeholder for however many there are. And I'm going to split it between 2 children, and I want to know how much each child gets. So you take your whole amount of crackers, C. We're going to split it, cut it, divide it, share it between 2 children. So C divided by 2. Again, like I said earlier, expressions are like instructions on how to find answers. when you know your information later. So if I want to know how many crackers each child gets, all I have to do is take the total amount and divide it by 2. That total could be 16. It could be 20. So these are instructions that tell me how to get my answer when I eventually know that information. All right, so anyway, c divided by 2. What is c divided by 2? Can I do anything with those? Are those like terms? Absolutely not. So all I can do is write them or the answer appropriately. So c divided by 2 is simply c divided by 2, and you can write that as c over 2. That's the preferred. Or c divided by 2 like we had. Or, if you remember our multiplication page, then we could write it like a fraction, as in 1/2 c. Notice the c is on the top, so if I move it off to the side, what would have to go on top? 1. So c over 2 is the same thing as 1/2 c. Kind of like, let's go back to our other example real quick. 4/5 w, again, was the same thing as 4w over 5. So the letter can be in the middle of the fraction or on top of the fraction. So c over 2, c divided by 2, or 1/2 c. They all mean the same thing. The first and the last are the preferred ones. Let's do a couple quick examples. Divide 10 by 5. Division can't be done in any order, so be careful with this. So divide 10 by 5, it's telling you to take 10 first and divide it by 5. Can I combine those and do stuff with them? Absolutely, they're both numbers. 5 will go into 10 twice. Let's try that with our last or next example. Divide x by 5. So it's telling me to start with the x. I want to divide by 5. What is x divided by 5? Again, x over 5. That's your preferred. Or x divided by 5 like we had it. Or the other preferred answer as a fraction, again, 1/5 x. So simply moving the letter off to the right side. Again, multiplying by a fraction is the same thing as dividing. If I multiply by 1/2, that's the same thing as dividing by 2. If I multiply by 1/5, that's the same thing as dividing by 5. That's why those two are the same. All right, last example. Divide the product of 7 and n by 5. So there are two things to do. First, product of 7 and n. Product means multiply. What are we multiplying? It says product of 7 and n. So 7 times n, that's going to be 7n if I keep it simple and write the most preferred way. Now what am I going to do? I'm going to divide the 7n by the 5. So 7n, divide it by 5. And I'm just going to jump to the preferred way as a fraction. So 7n divided by 5 as a fraction, 7n over 5. You could, again, write it like this, 7n divide by 5 like that. I'm going to circle this one. All right. I hope this has helped you understand how to write algebraic expressions. If it hasn't, there's a lot of information out there. I hope you find what you're looking for. You all have a great day.